All right, so in example 5, we're going to solve these logs. So what can I do?
Alright, let's just go ahead and slap them together. Let's make a little multiplication right
All right, so you're saying we can combine these because we got log plus a log.
So let's double distribute it.
So how do we combine them when they're being added? Multiply. So we got log of 3x, natural log, of 3x minus 2 times x minus 1. And that's equal to 2 times the natural log of x.
Ln x squared.
Okay, so you're saying to take that 2 and make it its exponent.
Oh, and can't we just subtract the 2 elements? Ln x squared.
Alright.
You probably could, but I think it's going to make it more difficult at the end. But you all want to go ahead and do FOIL right there? I think it'll help you see or distribute the binomials, multiply the binomials. So we still have our natural log. So all right, so we did our FOIL, we combined our like terms. Now what?
Well,
What do I have up there?
Oh, we have it in here.
We got a trinomial. Yeah.
Well, I have a log equals a log, don't I?
Yeah.
Even if it's natural log?
He crossed it out.
Yeah, so this is our one-to-one property.
Oh.
We have log base e is equal to log base e, so we know the log bases are the same.
And then move over that x2 and
So that means that 3x squared minus 5x plus 2 has to equal
get rid of that.
x squared.
x squared.
And so now we just need to solve for x. How?
Bring it over and then
Yeah, you got to make it equal to 0. So 2x squared minus 5x plus 2 equals 0. And you can either factor or you can use your quadratic formula, right? Alright, so if we're going to factor, let's do that.
Oh.
Remember, they multiply.
Let's slap that.
negative 5 1.
Slap it.
4 and 1?
Yeah. Flaw.
Both negatives.
You have to multiply to 4. And then don't forget to bring the 2 back. And remember, I factored all the way through. Some of y'all stopped short because we're just solving for x. And then set your factors individually equal to 0. So x minus 2 has to equal 0. And 2x minus 1 has to equal 0.
So if we ever get like x minus 1/2, you don't want us to just leave it?
So we got x equals 2 and x equals 1/2. But this had a log at the very beginning. So what do we need to do?
Can you natural log the numbers?
Yeah, you got to check them, though, and make sure that your numbers will work. So let's try that 2. So I'm going to plug the 2 into these. So what's 3 times 2 minus 2?
4.
Yeah, it's 6 minus 2, which is 4. Can we take the log of 4?
Yep.
Yes.
All right, so it's good there. So let's plug in 2 for the next one. 2 minus 1 is, can I take the log of 1?
Yes.
Good, so that one works. And then over here, it's just
Yeah.
2, so can we take the log of 2? All right, so 2 is definitely an answer, so I'm going to go box that. And then I'm going to check the 1/2.
Oh.
So we have 3 times 1/2 minus 2. Well, what's 3 times 1/2? 1.5 minus 2 is, it's negative 1/2, or at least we know it's negative, right? Because we're subtracting a bigger number. Can we take the log of a negative number? No, that didn't work. Therefore, x equals 1/2 is that extraneous solution we've talked about in the past. Means it worked for the problem as we worked it, but it doesn't work when we plug it back in.